Data replication ensures safety of data against undesired events such as crashes, and it can also provide high availability for massive load. In order to keep the replica servers updated, PostgreSQL provides a standard feature called streaming replication. This feature implements a mechanism to continuously ship and apply the world records to some other standby servers. Before we get started, let's see what capability streaming replication can bring to the system. First, we have failover. When the primary server fails, the standby server can take over operations. This means that we can build a high available system that can continue to operate if a failure occurs. Then we have load balancing. This means that read-only queries can be distributed among multiple servers. PostgreSQL streaming replication is implemented using master-slave configuration. The master, also known as primary instance, is read-write server where the slave is a read-only server. However, standard PostgreSQL doesn't have the distribution feature that considers the load on servers and where to send certain query. For that, we have to use load balancing tools such as pgpool or pgbouncer, which are open source extensions. These tools can efficiently distribute the load between serial instances. The lag on streaming replication is normally very short, depending on the network speed, database activity, and standby settings. Also, the replicated changes can be as small as single transaction. Therefore, the load on the primary of each standby is minimal, allowing a single primary to support dozens of standbys. Streaming replication is asynchronous by default. Therefore, the primary server doesn't wait for a confirmation that the changes we applied to the standby server. It sends back a response to client when it completes the processing on primary server. So the overall response time is about the same as when streaming going application is not used at all. However, since while shipping or data update on the standby servers is done asynchronously, the updated result on the primary server may not be immediately available on the standby server. So depending on the timing of the failover, data could be lost. Thus, this kind of replication is suitable for replication to remote areas of disaster recovery. It can also be useful for operations such as data migration and data loading in reporting systems. For critical systems, we can configure the replication to be synchronous. In this case, the primary server waits for a response from the standby server before completing the process. Therefore, the overall response time includes the duration of log shipping. However, since there is no delay in once shipping data, freshness of the standby server is improved. As a result, the system will suitable for failover and for rate-only load balancing distribution. Still, we need to be careful when choosing the sync mode since it affects the response time of the scale, processing, and high availability. Prior to work on hands-on to set PostgreSQL for streaming replication, let's first consider our objective. This lab session aims to establish a primary server that utilizes asynchronous replication to standby. Now let's take a look at the file structure we are using in this lab session. Both primary and secondary servers have the same file structure as /store/data. Now let's examine the IP addresses of both virtual boxes. All right. Now let's verify if Postgres is running. Okay, it appears that PostgreSQL is up and running in both primary and the secondary servers. So now let's check that the data folder is having the record permission so the database engine can write and read from the specified data folder. Okay, now the secondary had the record permission. So let's check that in the primary also. Okay, it seems the primary also had the record permission. So to begin, we will establish the primary instance. To achieve this, we will utilize the AnyDB command tool provided with your PostgreSQL installation to form a fresh PostgreSQL database cluster. If your PostgreSQL installation was successful, you should have access to this command. It seems PostgreSQL is encountering a permission issue. This is happening because we have granted read permission in slash data folder to Postgres user, but we are currently not operating as a Postgres user. Let's switch to Postgres user and then execute the initdb command. Running initdb will establish a fresh database cluster. Creating a database cluster entails generating the necessary directories to store database data, generating system tables, and creating the default Postgres database. Essentially, a database cluster serves as a centralized management. Now, the initialization process has successfully created a new database cluster. We need to make some configuration changes on the primary server before we begin. These changes can be done step by step. The first task is to modify the PostgreSQL configuration file, which can be located in the directory we have chosen. In this case, it's slash store slash data. Once the required changes are made in the PostgreSQL configuration file, we are ready to start the database. To start the database, we can use the pg_ctl command with the database directory which we specify. Next, we must create a replication user within the database. First, we connect to the default database name Postgres. Then we create a username rep user. It's crucial to ensure that this user has the replication privilege flag set. Additionally, we have the option to set a password for this user. The primary objective is to prevent the admin user from streaming the transaction log from the primary to the replica. The next thing to do is to control who is allowed to connect to Postgres server and from which IP. We do it via the host-based identity configuration file pg_hba.conf. We would add another line in IP4 mentioning here the replica host. User. The rep user is the user which just we created before. So I am using the rep user here. So once the required change is made, can save the file and we need to restart the server. If any config changes we made, we need to restart the server. So now our primary system is now ready and we can focus our attention on the replica. The next step is to create the replica. I will create one using the primary instance. To accomplish this, we will use the pg_base backup command, which connects to the primary and simply copies all the data files over to the replica. So now we are ready to give the pg_base backup command. So for that, we want to give -h, the host, which is the primary host name from where the backup to be copied. Next, we need to give the user, that's the rep user which we created in the primary. Now it makes sense to tell the Postgres to quickly make a checkpoint there. Now minus D, which is the data directory in the replica side. Then minus R. This slot will automatically configure our replica for replication. Now dash slot name and give some random name. I'm giving here the test or whatever name we can use. And minus C, so that the primary can automatically refresh the wall files, and specify the port. See, the PostgreSQL is complaining about the permission here also. So we will switch over to Postgres user because we set the permission to Postgres user to access the data files. Okay, now again use the pg underscore base backup command. The pg base backup command has copied everything over to its destination. A standby signal has been created confirming to the replica that it's indeed a replica. Configuration have been retrieved from the primary server. Now we have done all settings. So we can proceed to start the replica now. To start the replica server, we can use the pg underscore ctl command and dash d and the data directories which we copied by using the pg underscore base backup command and start signal. Oh yes, the server is started. So now the both the primary and replica are live. So after completing the setup, it's a good idea to explore monitoring and check the functionalities whether it's working as expected. We can check the functionality by shooting a command select star from pg underscore stat underscore replication on primary. So in the same way, we can shoot and command select star from pg underscore stat underscore wall underscore receiver from this replica. From the output, we can check the IP address of the client address from the primary and in the replica sender host IP address. It must be vice versa. Again, we can check in a real-time scenario like that. We can create a table in the primary and insert a value into it and check whether it's migrated or replicated to replica server by selecting the same table from the replica.